Hello, this is a recording of populations, samples, and sampling methods that you'll need to know about in order to properly design your study. So we talked about earlier how your measurement tools have to be valid. They have to measure what they say they are, they have to be well defined, and so forth. Your study also has to be valid. So does the study test what it intends to test? And you know already that this has to have internal validity, so the connections among your variables need to be causally linked, and we know that external validity means you can generalize. Well, what we're talking about today, populations and samples, relates to internal validity. And we're going to skip through this slide and go to this pot of beans. So imagining that you have had a bag of dried beans and you've cooked them and you think they might be done. And what you're going to do is very likely draw a sample. You don't want to have to eat the entire pot of beans to know if they're done. So you want to dip a spoon in and draw a sample of those beans in order to see if they're ready. Now, I would suggest, and maybe you would agree, that some of these beans might be more done than others of the beans. For example, if you never stirred them and you had your heat up a little too high, maybe the ones on the bottom are really done or even possibly burned. Maybe the ones on top, because they weren't fully in the water, aren't fully cooked. And so you're probably going to stir them before you take a sample. Stirring this pot of beans before you take a sample is the equivalent of taking a random sample. And once you take that spoonful of beans, you're going to likely, if the spoonful is done, you're going to infer that the pot is done. And that is the idea behind sampling. So you're going to stir the beans to get a random sample, and then you're not going to eat all the beans to see if they're done. You're just going to infer that they're done based on this sample. So that is the same as what we do when we're conducting a study. So we have a population of individuals, and we need to draw from that population a sample of individuals, because we can't often study the entire population. It's too many, it's too costly, it's too challenging to find all those people. And so we want to do our best to draw a sample at random, which means that every individual in this population has an equal chance of being selected, just like every bean in the pot, once you stir it up, has an equal chance of being selected. So we're going to stir the pot and draw our sample. And then, if we did our sampling well, we'll be able to infer that whatever it is we tested in our sample will reflect the population, just like that spoonful of beans reflected the pot of beans. And so population, again, is that group about which you want to draw conclusions. We may not be able to get data from all of them, so we take a sample. Why sample? Well, as we have already alluded to, sometimes it's just necessary. The population might be too large or inaccessible. It's practical. It's not efficient to attempt to collect data from all members of a population. It costs a lot to get survey data, and so we want to limit our numbers. And if we have a huge data set with every single member of the population in it, it can be prohibitive. And there are also statistical issues that can emerge with that sort of thing. So we want to really clearly define our entire population, and usually we need to do that in terms of subpopulations. So for example, if your original thought was that your population would be Diné College students, well, let's think about who you actually want. So do you want only full-time DC students? Do you want only female students, only non-traditional students, only non-traditional female Diné College students? Who exactly are you interested in? Who do you think your results can generalize to? You want to have a population that's somewhat homogeneous so that you can draw a good inference to that population. And so your sample is the group of individuals drawn from that subpopulation. And so sampling just means the process by which a sample is selected. Sampling bias is a distortion of the population that can occur when the sample doesn't represent the population, when you use bad sampling methods. And sampling error is a statistical term that just means that no sample is going to perfectly represent the population. So we're using a probability game. So this part right here is fairly important, as you'll see in part 2 of this lecture, because defining your population is half the battle. You have to be very clear. So as part of defining your population, you want to define exclusions. People who are part of the population but shouldn't be included in your study because they're different in some significant or systematic way from the population and would produce results that don't represent that population. So for example, if you want information about DC students, and let's imagine that I, a professor here, am taking classes, which I certainly will be doing, taking Navajo language classes and so forth. But do you want me, if you're interested in like some experience of Diné College students, do you want me to be in that sample? You might not, because you might be more interested in like full-time students who aren't faculty members, because maybe my experience, because I'm also a faculty member, is inherently different from the experience of students who are simply students without also being faculty. So why do you exclude people? So here are some examples, and I'll give you reasons to exclude people on an upcoming slide. So you might exclude people who don't speak English because they couldn't respond to the needed questions. If it requires that people speak English and you're not having a translation made, then you couldn't include people who don't speak English. That would be an example of an exclusion. If you are doing a study that requires fluent reading, and if the task that you're asking them to do, what you're measuring, is dependent on reading, and the individual has a lot of difficulty reading, then their data wouldn't be valid. They'd be part of a different population. You couldn't include them. Or people who are suffering from anxiety or depression. What if your study is asking them to reflect on a painful experience? You maybe wouldn't want to have people with anxiety or depression in that group because maybe they would be harmed. You definitely can't cause harm to your participants, and so maybe you would exclude people who are suffering from diagnosed anxiety or depression. So that's the kind of idea behind exclusions, and you'll need to think about that also. So our population parameters just is a term that refers to measures that describe the whole population. So IQ scores, for example, have an average of 100 and standard deviation of 15 based on many years of data collection from very large samples of people. Sampling statistics are measures that describe our sample. So if we decide to draw a sample of individuals representing the 18 to 20-year-old group to take the IQ test in 2023, then the individuals in this sample would provide data that we could use to infer about the population. And sampling error, when you have your statistics class, this will make more sense to you, but it's the amount to which the sample is off from the population or differs from what the population actually is. So if we have this population, we've drawn out these four, well, these might be randomly selected. If it is, it's good, or it might be a biased sample, and there's a chance that even if we draw a random selection, it still doesn't reflect the population. And that's what we mean by sampling error. Each sample we draw isn't going to be quite perfect. And so we try to just be aware of what the sampling error is, and that's part of our statistical calculation. Potential error, then sampling error just means naturally the sample isn't the whole population, it's not going to be perfect. But non-sampling error, or we might call it bias, results from poor sampling method, which we'll talk about coming up. Or you have a bad measurement, a bad questionnaire, or behavioral effects that occur during the experiment. All of these are sources of error that don't relate to sampling. So even if you use a really good sampling method like random sampling, there's still going to be some error. These things you should avoid through good planning. So types of sampling that are the best for minimizing, both minimizing sampling error and clearly avoiding those non-sampling problems is probability sampling, or we often call it random selection. So every single individual in the group, just like every bean in the pot, has an equal chance of being selected, like when everyone's name is put into a hat and a random drawing is held. It's not the same as haphazard sampling. Sometimes we think of random as just being arbitrary, but no, that's not what we mean here. We'll talk about that later. It's not the same as random assignment. That's a process we use to assign people to experimental groups. Like you bring in a sample of people and then at random you put one person in group A and the next in group B through a randomization process. And ways to get a random selection with a known population is you would list, so if you were getting all DC students, you would go to the registrar's office and get a list of all of those students, or whatever subpopulation you needed, and then you would use some sort of a random generator probably to link each one to a number and then pull numbers out of the hat. Or you could use bingo cubes. If you gave each person a number and then put in bingo balls, you could use something like that. But it's got to be completely random in order to represent the population well. And that's what that says. So there are several types of random sampling. First of all, there's simple random sampling. So that is drawing a subset of a statistical population in which each member has an equal probability of being chosen and is meant to be an unbiased representation of that group. So if you were asking the question, how prevalent is plagiarism at Diné College? The first thing you would do is define the population. And if you're staying with all DC students, then that's your population. If you want only, DC students who are freshmen and sophomores or something like that, then you'll have to specify that. Then you identify all members. You get your list from the registrar's office. You would put them in a list and give each member a number, and like it says here, place all names in list and assign a number to each and then randomly select numbers. And then you'd have to be really careful to collect data from everyone in that sample. Because if you don't, you can come into non-response bias, which we'll talk about in a moment. So this slide is actually talking about stratified random sampling. And in stratified random sampling, it's the same, let's imagine the same question, but you think freshmen, sophomores, juniors, seniors. By the time students are seniors, they would be less likely to plagiarize because they'll have learned more. So let's say you want to distinguish between that. Well, your population would still be all DC students, but now you're identifying groups, freshmen, sophomore, junior, senior. So you'd get all members of each group and list them, and then you'd figure out what proportion of all DC students are freshmen? What proportion are sophomores? Juniors? What proportion are seniors? And so then you would randomly select a proportional sample from each group using that same method and then collect data from each person. You don't ever substitute in another individual for someone who's in your sample. You can't ask your friend to step in. That would be a biased sample. And so it looks like this. Here's the whole population. Here we've divided this population into strata, which in our example is freshman, sophomore, junior, senior. And then we draw from each group. So we drew these two who are freshmen, these two at random who are sophomores, these two at random who are juniors, and so forth. Another type of random sampling is cluster sampling. And so again, if we're looking at how prevalent is plagiarism at DC, well, we might define our population again, and then we might identify clusters. And so let's say all classes that meet at 1 o'clock on Tuesdays, and each of those classes would be a cluster. And so this would be a cluster, this would be a cluster, this. Each of these are classes that meet at 1 o'clock on Tuesdays. And then you would randomly select not individuals, but clusters. We're going to take the 1 o'clock stats class and the 1 o'clock history class and the 1 o'clock Native American Studies class and the 1 o'clock French class, whatever it is. But you're going to randomly select clusters and then get all the individuals within each cluster. And the benefits, the reason for doing this is it would just be easier, wouldn't it? So you could ask the instructors about inviting participants and inviting their students and possibly offering extra credit as long as there was no coercion involved. And so that's another way that's a valid random sampling method. Once again, you make every effort to collect data from all individuals. Because if you don't, and I was going to say this before, a problem can emerge called non-response bias. And that means that the individuals who respond differ systematically from those who do not respond. So you can see that people who, let's say, were happy in their classes and they're coming to class a lot, those are the ones who respond. But those who are unhappy and not coming to class much, those are the ones who don't respond. Well, you can see now that you're getting a biased or distorted kind of data from your participants. You're getting happier data than reflect the entire population. That's non-response bias. So what more commonly happens is a type of sampling called haphazard selection, selecting a sample without a plan to ensure randomness. Convenient sampling is one of the most common, only sampling people who are easily accessible. We'll lay these out more in subsequent slides. Snowball sampling is asking friends who ask their friends who ask their friends. Voluntary request sampling is just requesting volunteers in some way and only using those who step up. Quota sampling, using convenient samples within subgroups instead of random samples from subgroups. And our problem is selection bias, the tendency for haphazard sampling to result in a biased sample because of differences between who's left out and who's included. So haphazard sampling, the first type is convenience sampling, and so the researcher asks friends, maybe, or people who are in their class or in some way connected to the researcher. So here's the researcher, and all of these people are connected to her. But the population she's interested in is much bigger than that, and the people she hasn't selected are farther away from her. And so they might differ in some way from the people that she chose. So she has a biased sample, people who are close to her who might systematically differ from the population. Not recommended. The second example is snowball sampling. Here's our researcher, and he asks two friends, who ask each of them some friends, who ask each of them asks friends, and so forth. So even though you have gotten a nice sample, these are all people who are in some way connected. And so just like in our previous example, they probably don't represent the entirety of the population. Sometimes you need to use this because let's say you're interested in studying people who have a fairly rare disease and there's no national database. Well, the best way to find those people might be to ask friends who have the condition to identify more friends who have the condition and ask those to identify more friends. So it's sometimes used out of necessity. If you have the opportunity to use random sampling, this is not recommended, but it might be necessary. Voluntary request sampling is sampling only those who come forward and volunteer. So, for example, feedback cards in restaurants only sample those who volunteer. If you ever call up, let's say a business, your internet provider or something, and they ask if you'd be willing to stay on to take a survey after you're done. Voluntary request sampling. Online email surveys asking for responses. We see a lot of those at TC. Course evaluations, only students who feel like responding respond. Product reviews, when you look on Amazon and you see all those product reviews, well, those are voluntary request sampling. And you can see what it looked like. The person put out a whole bunch of requests and only these people stepped up. And might they in some way be different? Yes, indeed. Maybe they have more time, or maybe they tend to be kinder, or for any variety of reasons, those who volunteer, maybe they have stronger opinions. but the likelihood that they're different is fairly strong. So that's not recommended if you have another way of gathering data that's random. Quota sampling will remind you very much of our stratified sampling, but here's the big difference. So it'll look the same like this. You're dividing your population into subgroups, just like you did here. And I have an example here of Chinle High School, Window Rock High School, and Shiprock High School. And you determine how many you need from each group based on proportions, such as 50 from each high school. And then you draw convenience samples until quotas are met for each location. So like you at a basketball game, you give a talk, and as soon as you get 50 from Chinle High School, you stop. No more from there. As soon as you get 50 from Window Rock, stop, and so forth. So the reason that it's not good is because it doesn't include random selection from within those subgroups. It's haphazard. It's sort of like first come, first serve, and so we're getting a biased population. And so quota sampling is not recommended. Stratified sampling is a better approach. We should be careful about sample size, and I'll talk about that a little bit more in the next lecture. But large samples are better at representing the population, but they're more expensive. And there's also some risks of having too much power so that little tiny effects show up as significant. So we have to find the right number in order to do this, and some things that we consider are how confident do we want to be. If we're doing a medicine that's life and death, we better be very, very confident. If we're just doing an interesting study that really isn't meaning that much right now, well, maybe 95% is good enough. Those are the things we think about, and there are tools that we'll use later. So your book frames all of this stuff in terms of descriptive studies. And descriptive studies are just questions, as we said, about how many, how frequently does something occur, that sort of thing. But even in experiments, you want to take some care to get a representative sample, but often we end up using convenience samples because they're the only people we can get to. Like, you might not be able to get to every member of the Navajo Nation, and so we choose those people who are nearest, but then we use random assignment to slightly overcome the limitations of sample selection, and we take care with how we're describing it in our study. And that's the end of this content.